Hello and welcome to another episode of Anything Arduino. Today we are going to make a bumper robot. I'm going to make it as simple and as cheap as possible so many of you can make it out there. We are going to use the stepper motor 28BYJ-48 like this, which if you buy it on eBay comes with a controller like this with a ULN 2003 chip mounted. So I bought 5 of these in a package for around $14 a while back, so fairly cheap. We're also going to use these simple miniature buttons for the bumper sensing, and we're going to make a small mechanism with a toothpick or matchstick or something like that. The platform will be made of a 8mm MDF board I had lying around, and also we are going to make the wheels out of this. So let's start with the software. There is a few libraries out there that nowadays that does support the 28BYJ-48. When I first started to look at this, I only found one, the Excel stepper, which also has acceleration and stuff like that. A very competent and good library that has a lot of examples as well here, and if you really want to make some really advanced stepper motor things with the 28BYJ-48, then you should look at Excel stepper library. But what I found that is a much simpler one for this quite simple project is an instructable by Mohanad Ravashte. Sorry if I'm pronouncing that wrong. He's done a instructable where he actually made a small sketch that does just what we want. We connect the 4 pins and voltage and ground, and simply what this one does is it turns, well, this exact sketch, it just turns one full rotation of the stepper motor, and then it goes one rotation back. So in this we see that this stepper motor has very high accuracy, and also you need to have 1 millisecond between each stepping through the motors, or else it will hang because it can't go too fast. So it's not a very fast motor, but it is very accurate. So he's made this little function loop here where you say how many steps it should take, and then it goes through all the steps in the stepper motor. So with this we can just make a small program which moves forward a bit, senses if any of the bumper sensors is pressed, and if it is, go back a bit, turn a bit, and then continue. So we start by connecting the first motor, that is in 1 on the ULN 2003 controller, to pin 8. Pin 2 is connected to pin 9. In 3 connected to pin 10. And then in 4 connected to pin 11. And then we also need plus
5 volts, which we later on use a battery for, but for the moment we use 5 volts from the Arduino. And also ground, of course. Connect that to the minus pool.
Okay, so now when we've connected it, let's upload this sketch there, and we'll see what happens. I put a bit of tape here so you can see, and so it waits for 2 seconds and then it sends 4095 steps to the motor. And so on. Okay, so we have that. Now, the first thing we need to do in the software is we need to add another motor. I'll go through the code from start to bottom here to explain what has been done. First thing we did is we duplicated all of Mohanad's code. So we have defines for the 4 ins of stepper 1, which is in 1.1, in 1.2, in 1.3, in 1.4. And then we did the same for stepper 2, in 2.1, in 2.2, in 2.3, in 2.4. And these pins here. And how we connected it is like this. So when you get it in the package like this. You just simply plug this in here. There's only one way it can go. One goes into 4, 2 goes into 5, 3 goes into 6, and 4 goes into 7. There. So plus 5. The breadboard. And there we go. And then we have the bumper sensors, which I'm going to go through in a while how to connect. So steps 1 and steps 2 is for the 2 motors. Once again, we have to duplicate that. We have to duplicate the direction 1 and direction 2. And this is how we go through how the wheel should turn. So direction of wheel 1 is true and direction of wheel 2 is false. Then it goes backwards. And true turns right, false turns left, and false true goes forward. So that, depending on how you mount your motors, you have to just make sure this is correct. And we did the same steps left for the 2 motors. And in the void setup, we once again make the 4 inputs for the first motor and for the second motor 2 outputs. So let's go down in the code to. So here is his function Mahanet's function for stepper. We do a stepper 1 and then we duplicate that to do a stepper 2. And also in that function he calls another function for set direction, which we also duplicate to set direction 1 and set direction 2. So in the stepper 1 we use the in11, in12, in13, in14, and in the stepper 2 we use the in21, in22, in23, in24. So the two different motors. And also set direction 2. So in the two set direction functions, it's just for the different motors, set direction 1, and here is set direction 2. So duplicated all his code. And in the loop we do a while 1 is greater than 0, which is always, so the robot will always run. First thing we do is we check the bumpers, the left and right, and then, so here we have if, here's the first if for the left bumper. If the left bumper is high, if it is pressed, then we go back a bit, so steps left 1 and 2 is 1024, so this is a quarter of a turn. And then we do a while loop for as long as the steps are larger than 0, and then we go backwards, which was direction 1 true and direction 2 false. So we go backwards, for the, this is just another copy of Mahanet's code, and milli, so we need 1 millisecond for the motor to react between the pulses. So after we've backed up a bit, we are going to turn right. So once again, quarter of a turn on each wheel, which becomes about 45 degrees. And direction 1 true, direction 2 true, which is turn right. So we do that, and another copy of the loop. And then after we've done that, we check if the right button is pressed. Usually they're not pressed at the same time, and usually if the left button was pressed, then this is done. So the right button is probably not pressed. But this exact same thing, back up a bit and turn left instead, of course. And then if none of these are true, then we just, or when they are done, we continue current millis, direction, we send 1 step and we change the direction to forward, and we send 1 step to the first stepper and 1 step to the second motor. And well, this never happens. I can take that away again, because there is the while loop ends there, while 1 is bigger than 0. So then it just goes on. So it will check the bumpers. If they're not pressed, move forward 1 small step, and then it will check again, move forward 1 step. And this is so fast, so it actually looks like the robot is moving. So very high accuracy in each step, because we have 4,000 steps for 1 whole rotation, and it checks the bumpers for every step of the way. So there's no need for debouncing and stuff like that because of this code. And that's it. That's as small as the code is, or as simple as the code is. And if we compile this, you will see that it is actually only 3K large. So a very small and very simple sketch with loads of memory left to do a lot of different stuff. So there's place, at least software wise, for a lot of more sensors. At the moment we do use a lot of digital pins, but all the analog pins are still available, and a few of the, I think there's 2 digital pins left unused. No, actually, yeah, 4 digital pins left unused. So there's a bit more room to add stuff. Okay, before we continue with the software, I want to build the platform and put the motors on and the wheels, so we can in the code may see what kind of movement we need for it to do what we want. So I'm going to fix this up, make this square. It's not square right now, so so the wheels will be parallel. I'll make indentation holes for the motor and screw the motors in just like this, straight into the MDF board. And I'll take away some here and just put a gliding plate on the back so it can move freely. For the wheels, just to make this as cheap and simple as possible, I have a hole saw set. So this is one of those saws or drills that you put one of these on for when you want to make a hole for electricity outlet or something like that. Which means that I can choose whichever size of the wheel I want. I'm thinking of taking this one. So we'll make 2 wheels out of this. I think the drill is a bit large, but we'll fix that. We'll put everything together with some kind of glue. I'm going to use hot glue, hot glue gun, but you can use any type of glue you want. So this one is 2.8 centimeters. So it's going to look something like this. Something like that. And yeah, we're going to keep the wheels there. So let's do this. Bit of rough edges I might have to fix. So why I do this is because it's much easier to take it away. You just take a chisel like this, or if you don't have a chisel, just take a knife and well, you can break away the really short ones or the thin ones, and you just work with the chisel or the knife for a bit and you will get a straight hole. So here is the final platform, and it might have been even easier with a normal knife, but oh well. Let's see if this works. Let's put on the motors, and also I have to finish up the wheels a bit. I think I have to find a knife for that. There, let's go and see if this works. Okay, so let's start by gluing on the wheels. No, we're not gonna start with that, but we're gonna see. So it's a bit loose, but that really doesn't matter, as we're going to just fill it up with glue and that will take care of that. Fitting fits quite good, I think. And if we put it like that, the wheel will be a bit lower. That is too low actually, so yeah, we put it like this. Oh, wheels are done. So that's done. Now we just need to have something here to straighten it up a bit. We can, however, check functionality anyway. See what happens. Look, we're turning! And turning back. Cool. We have a working robot. Well, kind of. One of the wheels isn't spinning that good. Okay, let's find a little cap to put here. Okay, so I found this one lying around. It's one of these things that you have for corners, so your kids won't run in and hurt themselves. So we're just gonna put a big slab of glue there, and that is going to work perfectly. Actually, before it dries, just like that. There. So we have much better adhesion to the surface when we put on some glue on the wheels. Great. Now for the bumpers, we are going to need 2 matchsticks. If you want to be on the safe side, you should chop this the sulfur off. I'm going to leave it on because, well, they won't catch fire. These matches won't catch fire by just bumping into things, unless you come with a match box and bump into that. That might. But matches are different all over the world, so make sure that you are safe and either cut them off or do something else. And we're going to need 2 of these I've just soldered 2 pieces of wire on them so I can attach them to my Arduino. We're once again going to build this using a hot glue gun. Okay, so this one has heated up now. I'm going to put some glue on here and let's see if it catches fire. So it didn't. Good. So now it's a bit safer and we have a bigger bumper. I'll just hold that then. So on the robot we're going to let these stick out about like that, so it's about the same width out as the wheel, and we'll just glue it to the side here. Just the bottom of the match, nothing more. There. So now it should be a bit springy. This one is going to be. So then we take our button, and depending on what material you have, you might have to push the other pins aside. So, and that one should be like that. So when we bump something, it pushes that button like so. And the further down you move it, the more sensitive it will be, and also the less bump back we will have. So I think that is a good place. So we just glue our button in place, and then just one little piece of glue between the button and the matchstick, so they will stick together, but not so it will impale the functionality of the button, which I think I just did. There, fixed. Sticky stuff. So let's do the other button. It works fine. We go into a wall or something, and it will press the button, and it will press this button. And kind of sturdy at the moment, at least. And lots of glue everywhere. So we connect it to the Arduino. One end of the buttons you connect to plus 5 volts. And then the right button you connect to pin 2. And the left button to pin 3. And then also
you connect both buttons to ground via a 10K resistor. Like so. So this way we will have no floating values. It will be either +5 or 0.
Moving forward. Bumping into something. Bumping into something else. Yes. So one more thing to do on the hardware side. And that is get a battery on here so I don't have to have it connected to my computer all the time. So as always, there's a few different models to choose between. There's this one where you use 4 AAA batteries, two AA batteries, or you have this 9-volt battery. So I'm going to use this 9 volts. And to get more traction in the motors, I can actually, because these can take 5 to 12 volts, so I can actually connect the motors directly to the battery. So we are going to do that as well.
So the 9-volt battery is connected to this connection right there, 9-volt battery. And because of this, we are going to take away this 5-volt connection there, and instead we are going to use the V-in as an output to the motors. V-in. Because that's the voltage input, so we actually get 9 volts directly to the motors from that pin, and then we continue with the 5 volts to the buttons, because we still need 5 volts for the logic of the buttons, or else we will break the digital input ports. So with this setup we get much more power to the motors.
Let's see if this works. Yes. Awesome. Cool. So let's go and try this out someplace else. So after I moved the buttons a bit closer to the base of the matches, the bumpers works much better and are much more sensitive. Still room for improvement though. But with this, this episode of Anything Arduino has come to an end, and it was quite a long episode, but we did make a whole robot, so I think that is okay. I also checked the prices on eBay, and with the prices today you can actually make this with everything except the wooden parts and the matchsticks. I did not count those in, for less than $10, and that is including an Arduino platform, Arduino Uno, and the motors, and 100 of these little micro switches for less than $10. So a really cheap robot, and I think it's a good platform that we can keep building on. You can find the code on Arduinos.net as usual, and if you like this, please click the like button. Please subscribe if you want to see more of this. And well, if you make one of these, I really want to know and see your robot that you make with this. And I also passed 1,000 subscribers just the other day, so I just want to say thank you to everyone who's subscribing. It's really fun to know that this is actually fun for more people than me, and yeah, it's cool. Please let me know in the comments anything you want to ask or suggestions on more episodes to come. Until next time, take care.